This is Geometry B, Unit 5, Lesson 4. Unit 5 is on area, Lesson 4 is on perimeters and areas of similar figures. We are going to examine the relationship between what happens when an object grows or shrinks, a dilation, and what happens to the scale factor for perimeter and area. So let's take a simple case here. I'm going to start with a little square, just a square. And each side is 1 unit long. So the side length, I'm going to give the length. Length is 1. I'm going to give the perimeter. The perimeter is 4. And I'm going to give the area. The area is 1 times 1, or 1. Okay? So that's for a single square, right? Now let's double the dimensions of the square and make all the sides 2. And let's see what happens to these now. So we had a side length of 1, now we have a side length of 2. The side length is 2. The perimeter is 2 times 2 plus 2 plus 2 plus 2, or 2, 4, 6, 8. The area is 2 times 2, or 4. Okay, now let's expand it out to 3 by 3. The length is 3. The perimeter is 3 plus 3 plus 3 plus 3, or 3, 6, 9, 12. And the area is 3 times 3, or 9. Let's do one more. Let's do a 4 by 4 square. Okay, so the side length is 4. The perimeter is 4 plus 4 plus 4 plus 4, 4, 8, 12, 16. The area is 4 times 4, or 16. Now let's do one more. Let's do a 5 by 5. Okay, the side length is 5. The perimeter is 5 plus 5 plus 5 plus 5, or 20. And the area is 25, 5 times 5. Okay, now I want to notice what happens to each of these here, right? 1 to 2 to 4 to 8. Okay, 1 to 2 becomes 4 to 8. You notice we can get these numbers by multiplying by 4 times 4, right? And so actually the ratio of 4 to 8 is the same as the ratio of 1 to 2, because all I need to do is divide both by 4. So divide by 4, divide by 4. 8 divided by 4 is 2. So this reduces, if you like, the ratio of 1 to 2, okay, which can be expressed as a fraction, is the same as the ratio of 4 to 8. They're the same, right? So the ratio of perimeters is the same as the ratio of lengths. Now areas is another matter. 1 to 2 is not the same as 1 to 4. So the question is, what is the relationship going on there? Same with the next pair. 2 to 3 is not the same as 4 to 9. And 3 to 4 is not the same as 9 to 16. And 4 to 5 is not the same as 16 to 25. So what is? What gives? Well, the answer is this. 1 to 2 squared is the same. 1 squared is 1. 2 squared is 4. 2 squared is 4. 3 squared is 9. So 2 squared to 3 squared is 9. 4 to 9. Okay, 3 to 4 squared is 9 to 16. 4 to 5 squared is 16 to 25. So here's just a summary of what we're finding here. If the ratio between two similar figures is A to B, then the ratio of the perimeters is also A to B. But the ratio of areas is a squared to b squared. Okay, that's in a summary what we've discovered. If the ratio of similarity between two similar shapes is a to b, then the ratio of perimeters is also a to b, but the ratio of areas is a squared to b squared. Let me show you how that's going to be used in problems. Okay, let's say we got some shape, some irregular shape, and it's got a perimeter of 9. Okay, and we've got some other shape that is similar to it, so it's the same shape, just different size. Okay, and let's say this is a reduction, so it's smaller, and the perimeter of this is 6. And let's say the area of this larger one is 24. What is the area of the smaller one? The area of the smaller one. Well, the ratio of similarity between the two is 9 to 6. Okay, that's the ratio of areas. That's the straight ratio of areas or ratio of perimeters. The ratio of areas is 9 squared to 6 squared, right? 9 squared to 6 squared. Now we can simplify that, but I'm not going to. 9 squared is 81. 6 squared is 36. So the ratio of areas between the left and the right is 81 to 36. So write and solve this proportion. 81 is to 36. That is, left is to right. 81 is to 36. As 24 is to x. As 24 is to x, or a, or whatever letter you want to use. Okay? And then cross multiply and divide. So multiply 24 by 36 and divide by 81. Okay? And we can do arithmetic by hand, or we can do it by calculator. I'm fine with either. 24 times 36 divide 81. 10 2/3. 10.666 is 10 2/3. Okay? And so that's the area of the smaller shape, 10 2/3. And it makes sense. It's actually less than half the area. And that's kind of interesting. When when ratios of dimensions change, the areas change faster. Okay? That's really the idea behind this lesson.